Question 16 reads, a negatively charged particle enters the space between two parallel plates, moving across the page from right to left in the presence of a uniform electric field directed towards the top of the page. Determine the direction of a uniform magnetic field that could result in a zero net force on the moving charge. So I've drawn the scenario below. I have two parallel plates, and then I have a negatively charged particle or an electron traveling from right to left. So the first bit of information that we want to focus on is the presence of this uniform electric field that's directed towards the top of the page. So I know conceptually from the electric field concepts that an electric field travels moves towards the direction of the negatively charged plate, and that's because we determine the direction from whichever way the positively charged test charge will travel. So if I have a positive test charge, then I know that it's going to want to travel towards the negative side, because a positive and negative charge are attracted to one another. So I know that if the uniform electric field is directed towards the top of the page, then this top plate must have a negative charge. And then this is really important because it will help us a little bit later determine where this particle is going to be attracted to. And then so since this top plate is negatively charged, then I know the bottom plate is positively charged. Positive. And then so this is where you want to consider what sort of particle you have, whether it's positive or negatively charged. And so since we have a negatively charged particle, then we know that this particle is going to be more attracted to the positive side. So the trajectory of this is going to potentially move towards the positive charge. And so we need a force that will balance this force towards the bottom of the plate, and that will result in a zero net force. So if the electron was traveling at a constant speed. So if we want a force that will oppose the force moving downwards from the attraction of the electron to the plate, then we need a force that is moving upwards. And so this force can come from the magnetic field, but we have to orient the magnetic field in the correct direction in order to obtain this force moving upwards. And so if we take our right hand and we use the right hand rule, then we know that our thumb is going to want to travel to the right. So our thumb is going to be in this direction, and then we know that since it's a negatively charged particle, that a force would be coming out of the back of our palm. And so if we were to orient an arrow coming out of the back of our palm that was faced towards the top of the page, and we had our thumb in the direction of the current, then we know that our four fingers, which are representative of the magnetic field, are going to go into the page. So that is actually the answer to the question. The magnetic field will be going into the page. So that the answer is letter E.